Welcome back. So today we're going to be working on our regular polygons foldable. So if you want to go ahead and take out your foldable, it should look like this. We're going to start with the triangles up here at the top. So if you want to go ahead and open that one up, I do have this zoomed in, so hopefully it'll be a little bit easier for everyone to see. So a couple things that we have on these. Since we're finding area of regular polygons, I have the A, the lowercase a, P, and the capital A that are already on there because those are the pieces of information that we're trying to find. So for this first one, it is an equilateral triangle or a regular triangle. So we're going to be finding the area of that. So the first thing that we need to do in order to find the area is we're going to find our central angle. Okay, so in order to find the central angle, we're going to take 360 divided by the number of sides. Okay, so in this case, it's going to be 360 divided by 3. So then our central angle ends up being 120 degrees. Now remember, our central angle goes from one vertice to the other, so it's 2 radii. So this big angle in here is our 120 degrees. Okay? So now in order to find the smaller one that we have down below, we're going to take the central angle and we're going to divide by 2. So central angle and we're going to divide that by 2, which gives us 60 degrees. Sorry, I had a mistake there. So 60 degrees here. All right. So from there, we have a 30, 60, 90 triangle because we know this piece is going to be 30. So we know with every 30, 60, 90 triangle, I'm actually going to flip to the front side of our foldable. Okay, so we just said this was 60 degrees and this one is 30. With every 30, 60, 90 triangle, our short leg is in, our hypotenuse is 2n, and the long leg is in square root of 3. Okay, we're going to be using this information to help us solve for the missing piece over here. So if we know that the hypotenuse is 4, that means the short leg is 2. So that represents our apothem. So the apothem is 2. The long leg is the short leg times the square root of 3. So this is 2 square root of 3. So that means the side of our triangle is twice as long as that. So we're going to take 2 times 2 square root of 3. This is 2 times 2 square root of 3. Okay, that gives us 4 square root of 3. So then we need perimeter. So for perimeter, we're going to take 4 square root of 3 times the number of sides, which is 3. 4 times 3 is 12, and then we still have that square root of 3. So our perimeter is 12 square root of 3. To find area, if you don't remember, area is up here on the front, 1/2 P times A. So area equals 1/2 perimeter, which we just found to be 12 square root of 3, times A, which is 2. Now I'm not even going to use a calculator for this piece because 1/2 times 2 is 1. So this is 1 times 12 square root of 3, which is just 12 square root of 3. Our label is inches squared. Okay? All right, so we're going to do one more triangle. This time they give us a perimeter of 96 square root of 3. So we can go ahead and fill that in, 96 square root of 3. So I'm going to draw my picture. If the perimeter equals 96 square root of 3, to figure out one side, I'm going to divide by 3. So that gives me 32 square root of 3. Okay, now if you remember back to the other one, we need half of that because we're going to work with this little triangle here. So half of this would be 16 square root of 3. Now if we look back, we have this piece down here, we need the apothem. So if this is 16 square root of 3, the apothem is going to be 16. So now that we have the apothem, we're going to go ahead and plug it into our formula. A equals 1/2 times 16 times 96 square root of 3. This one you will need a calculator for. So go ahead and multiply those together. 1/2 times 16 times 96 gives us 768. We still have the square root of 3. And this one is going to be units squared. Okay, so those are for our equilateral triangles. Really important to have this piece on the front so that you can refer back to that as you're working through trying to find side lengths, apothems, or radii. Okay, let's move on to the quadrilateral or square. So same formula. Okay, so this time we're going to find the area of the regular quadrilateral, starting out again with our central angle. Central angle is 360 divided by the number of sides, so that would be 4 in this case. So we end up with 90 degrees. So that's a 90-degree angle there, or you can put 90 degrees in there. We need the piece, which is half of that. So half of 90 gives us 45. So for this triangle, we actually have a 45, 45, 90. So we're going to go back up to the front, and we're going to mark this as a 45, 45, 90. And we're going to go ahead and label our sides again. So we know the two legs are in, and the hypotenuse is in square root of 2. So we're going to be using this information to help us. Okay, so coming back over to number 3, if the apothem is 10, go ahead and fill that in. We know that the other leg also has to be 10 units because the two legs are congruent. We need to find perimeter, so a whole side. If this piece is 10, the whole side would be 20. So for perimeter is 20 times the number of sides, which is 4. So we end up with a perimeter of 80. Now that we have both pieces, we're going to go ahead and plug that into our equation. A equals 1/2 80 times 10. Okay, so again on this one, I'm going to take half of 80, which is 40. 40 times 10 is 400. So this is 400. It's going to be inches. So inches squared. Okay, great job with that one. Let's keep moving. So the next quadrilateral. This time we have a perimeter of 16 centimeters. Okay, so we're going to go ahead and fill that into the perimeter spot. I am going to go ahead and draw my picture. So if we know that the perimeter is 16, each side, we would take the perimeter divided by 4, which is 4. So then when we're finding the side length for our triangle, that's going to be half of the whole side, which is 2. Since this is a 45, 45, 90 triangle, we know that our apothem is also going to be 2. So now we can plug that information into our equation. A equals 1/2 16 times 2. Now again, half of 2 is going to be 1. 1 times 16 is just 16, so that's 16 centimeters squared. Okay. All right, so that is the quadrilateral. The last one that we have is the regular hexagon. So for that one, again, we're going to start with that central angle. So we're going to take 360 divided by the number of sides, which in this case is 6. So we end up with 60 degrees. So the central angle is 60 degrees. We need to find this piece. It's going to be half of the whole central angle. So that's 30. So then this is going to be a 30, 60, 90 triangle again. So let's go back to the front. We have 30 degrees here. We have 60 degrees there. So we have our 30, 60, 90. We know that our sides across from the 60, we're going to have our n square root of 3. Across from our 30 is going to be n, and then 2n for our hypotenuse. Okay. All right, so we're going to be using that information to help us with this one. So if we know that the whole side is 24, then the piece that we're looking at here is going to be half of that, which is 12. So that is our n. The apothem is our n square root of 3, so that would be 12 square root of 3. For perimeter, we're just going to take this side length times 6. So perimeter equals 24 times 6. On your calculator, we should end up with 144. So we'll plug that in. So then the last piece is to do the formula for area. Area equals 1/2 144 times the apothem, which was 12 square root of 3. So you can go ahead and punch that into your calculator. So that ends up giving us an area of 864 square root of 3. And then our units for this one is going to be centimeters squared. Okay, so let's go ahead and move on to. So the second example that we have, this time they're giving us the perimeter of 24 units. So we can go ahead and fill that in down here at the bottom. And so we're going to go ahead and draw our shape again. So just kind of sketching a shape, doesn't have to be great. So drawing our shape there, if we have the perimeter of 24, we need to find one side's length. So we're going to take 24 divided by our 6. So that ends up giving us 4 for one side. And then we need half of that to get the leg of our triangle. So that gives us 2. Since this is a 30, 60, 90, this is our short leg. This one is the short leg times the square root of 3. So that's going to be 2 square root of 3 for our apothem. Okay, so then from there, we can go ahead and plug everything into our formula. A equals 1/2 24 times 2 square root of 3. Go ahead and multiply that on your calculator, or you can just take 1/2 and the 2 is going to cancel each other out. So we're left with 24 square root of 3. And our label for this one, units squared. All right, that is all that I have for you today. Have a great day. I will see you in class. Bye.